Hey guys, in this video we are going to discuss about three types of machine learning techniques. Usually all these machine learning techniques are related to some kind of problem statement. First of all, let me just call out all the names. So the first kind is something called as supervised machine learning technique, and the second type is something called as unsupervised machine learning technique, and the third type is called as reinforcement machine learning technique. And all these techniques that we will probably be discussing will be with respect to some specific problem statement. Okay, so let me go one by one and let me explain you. So first of all, I'm just going to consider supervised ML. Okay, supervised machine learning technique. Supervised ML technique. Now in supervised ML technique, what happens is that, let me give you a very basic example. Suppose my task is to predict the house price. Okay, so I really want to predict the house price. And let's say I have a specific data set. Okay, in this particular data set, I have some features. Let's say I have features like the size of the house. Okay, number of rooms in the house. Number of rooms in the house. And then I have my third feature, which basically indicates the price of the house. Usually in a supervised machine learning technique, you get this kind of features and you divide the features into two different categories. The first category is something called as independent features. Okay, so both the features are basically called as independent features. Okay, and one more feature that you see over here is something called as price. This price is basically called as your dependent feature or your output feature. Okay, similarly, when I say independent feature, these are also my input features. Now let me give you some of the data points as an example. Let's say that the size of the house is 5,000 square feet and number of rooms are 5. So the price of the house will be $450K. Okay, similarly, let's say your size of the house is 6,000 square feet, number of rooms are 6, then this will become $500K. Like this, you will be having a lot of data points and this will basically be your data set. Okay, in short, over here, why this feature is called as dependent or output feature, because this value keeps on changing as the input value changes or as your independent feature changes. One more very important thing to understand about supervised machine learning technique is that there are two types of problem statement that we usually get to solve. One is regression problem statement and the other one is something called as classification problem statement. Now, what is the basic difference between regression and classification and problem statement? Okay, in regression problem statement, whatever dependent or the output feature you will be having, all those feature values will be continuous. Okay, it will be continuous. Okay, so two important thing with respect to supervised machine learning technique is that, first of all, you will be having a specific output or dependent feature. Okay, so first point is that in supervised machine learning technique, you will definitely be having a dependent or output feature. Okay, the second point is that if it is a regression problem statement, then your output feature will be continuous. If it is continuous, you can directly consider that this will be a regression problem statement. Okay, but if this is not continuous and if this is categorical, then what kind of problem statement this will become? This will become a classification problem statement. Let's say I'll give you a basic example. Okay, I have one classification problem statement as an example. So here is my classification problem statement. And let's consider I have features like number of study hours, number of play hours, and here with respect to this specific output, let's say the person is either passing or failing. So let's say I have a data set which has these features. Here my input features are number of study hours, number of play hours, and based on that we really need to determine whether the person is going to pass or fail. So this becomes my dependent feature. Okay, and this all becomes my independent feature. So here, let's say if the person is studying for 7 hours, if he's playing for 3 hours, that basically means he's going to pass. Okay. If the person is probably studying for only 2 hours, is playing for 6 hours, he may probably fail. Okay. So this kind of features. Now here, the output feature is fixed number of categories. If there are only 2 categories, we basically say it as binary classification. Okay. If there are only 2 categories, then we specifically say it as binary classification. Or if there are multiple categories, suppose let's say there are also one more category like maybe he may pass or fail, he or she may pass or fail, then this becomes a multi-class classification. Okay, so usually we get 2 types of problem statement even in classification. It can be a binary classification or multi-class classification. The basic difference between binary and multi-class classification is that in binary classification, you just have 2 fixed categories, that is either pass or fail. That is binary, right? 2, right? In the case of multi-class, you may have more than 2 categories, and you really need to train the model with respect to this specific input, and you need to probably predict it whether the person is going to pass or fail, right? So this is the basic difference, or this is the types with respect to the supervised machine learning. Again, let me revise it. In supervised machine learning, you basically see 2 types of problem statement, regression and classification. And why do we say supervised? Because here specifically you have a dependent feature. Okay, dependent feature should be there. Then only we will be able to say it as supervised. Then only we will be able to train our model with this specific data set. And later on, whenever we give a new input data to that specific model, it will be able to predict. Okay, so this is with respect to supervised machine learning. Now let's go ahead and let's try to talk about unsupervised machine learning. So the second type is something called as unsupervised machine learning. Now, what is the basic difference between supervised and unsupervised? Okay, let me again give you a basic example. So this example is related to something called as customer segmentation. Okay, whenever we work with respect to unsupervised machine learning, one very important thing that you should know that we do not know the output feature. Over there, we don't need to predict anything. Instead, we need to find out similar clusters or groups. So if I take an example with respect to customer segmentation and I have a specific data set, let's say this data set is something like salary. I have a feature like salary. Then I have something called as spending score. Okay. Spending score. Let's say I have this 2 specific feature. The spending score is given between 1 to 10. That basically means how much the person is spending. The more the value towards 10, the more that specific person is basically spending. Okay. So let's say this salary is 20,000 rupees. Okay. 20,000 rupees INR, $20,000. And let's say the spending score is somewhere around 9. That basically means this person spends more, right? Suppose if I say the salary is 45,000, okay. It can be in dollars or INR or anything as such. Okay. Then let's say that spending score is 2. What does this basically indicate is that obviously the person is earning more when compared to this person, but his spending is less. So he does not like to spend much. Similarly, I may have a lot of data like this. Okay. Now, in this particular data set, I just have my features. Here we don't say that, okay, this is my output feature. Okay, I don't have to predict that based on the salary, what will be my spending score. No, that is not the aim. Tomorrow, let's say I want to launch a product. I'm an e-commerce company. I'm running an e-commerce company. And this e-commerce company, I've launched a product. And I want to send a mail with some discount coupon. Mail with some discount coupon. To this people based on the spending score. So how do I send it? What I do is that with the help of unsupervised machine learning, we create clusters. We create clusters. Now, let me give you an example of clusters, how it will be. So let's say that, okay, what we do is that we create similar clusters. So let's say this group basically is the group which has higher salary and which are spending more. Okay. Let's say I have one more group. These are basically having less salary and they are spending. See, if I probably say salary over here and spending over here, right? So these are the people who have median salary and they spend more, right? These are the people who have less salary and they spend less, right? So these are the people. And so we are going to make this kind of clusters or groups over here, right? Let's say this is another group which has huge salary and spending is median, right? In the medium, like in the mid, right? If I have one more cluster, I can have one more cluster which is somewhere here. And probably these people are having the highest salary and the spending score is also high. So if why we do this specific thing is that tomorrow, let's say that if I'm launching any product, I would definitely give this people some discount so that they will be able to buy my product because their spending score is obviously high and the salary is also high. So in short, in unsupervised machine learning, we create something called as clusters. Okay, clusters, and there are various kind of algorithms that we specifically use. I'll talk about different kind of algorithms as we go ahead. Okay, now let me talk about all the algorithms that we are going to learn in supervised machine learning and in unsupervised machine learning. Okay, so in supervised machine learning, we will start with something called as linear regression. As I said, two types of problem statement we will be solving. One is regression and one is classification. So first we'll start with linear regression, then we will go with ridge and lasso regression. Again, this is basically to solve a regression problem statement. Then we will be learning about elastic net. This is also used for solving regression problem statement. And then we will move towards classification. So classification, we will be seeing something called as logistic regression. Okay, so this is basically my classification. Okay, then we will go with some algorithms, and this algorithm can actually help us to solve both regression and classification problems. So here we will be learning about decision tree. Okay, we'll be learning about something called as random forest, ADA boost, right? We'll be learning all these algorithms slowly. We'll also be understanding how to implement it practically. Then we will be seeing something called as XGBoost, random forest. These are something called as bagging and boosting. And with the help of this kind of algorithms, right, we can solve both classification and regression. Okay, and regression problem statement. We can solve both of them. Okay. And ADA boost, XGBoost, CAT boost is also there. So we'll try to solve all this thing. In some unsupervised machine learning, we will try to learn about algorithms like k-means, hierarchical mean, okay, hierarchical mean algorithm. Then I also have something called as DB scan, DB scan mean, DB scan clustering. Okay, so these are all clustering algorithms. Okay, specifically we'll be using something called as unsupervised machine learning technique so that we can create some amazing clusters and groups, right? So this is with respect to supervised machine learning and unsupervised machine learning. Okay, and let's go ahead and let's talk about something called as what about the third one, which is called as reinforcement learning. So in reinforcement learning, this is also an amazing module altogether. And it is completely different when we compare it with supervised or unsupervised machine learning, because here the application will learn things by itself, by getting some amazing rewards. The best example that I can probably take with respect to reinforcement learning is that, just for right now, because we'll be having a separate module for this also, is that whenever we consider a baby, right? You have seen a baby, right? When it is very small, it will not know anything. But as it keeps on growing, right, it learns new things. So let's say it is trying to walk for the first time. So when it is walking for the first time, he or she may fall down. And when he may or she may fall down, at that time what happens? He or she may cry, right? Because when she or he is actually falling down, they may get some kind of sore in their leg and all, and they may get hurt, right? Later on, what they do is that they make sure that they slowly learn things so that they should not get hurt. So that basically means they will try to do things by getting some amazing rewards, right? And you've seen children, right? If they bring good marks in their high school or college, the parents gives them some kind of rewards, right? So based on that specific action is actually done, right? So similarly, reinforcement learning also works in that way. Don't worry about it right now because we'll be having this module as we go ahead. Okay. So this was the basic difference in making you understand between the three types of machine learning. We'll start with supervised machine learning technique. Probably our first algorithm is linear regression, which we specifically say it as simple linear regression, where we'll be learning how this algorithm works, and we'll be learning about ridge, lasso, and all. And we'll go in this specific order, and we'll convert first supervised machine learning, then we'll go with unsupervised machine learning, and then we'll be learning all these things, right? So yes, let's continue with the next video. Thank you.